Hello there guys, it's Redstone. Today I will be demoing a project I made using with a Clanker. So what the Clanker and I have designed is a experimental programming language. So what's this so-called programming language? Glad you asked. So this language is a Lua inspired statically typed programming language which contains Rust's result and option types. So I'm going to explain a bit about the programming language. So here we go. The project is written using the Go programming language. As you can see here, it's written using the Go programming language. So and we had some plans to include Rust in it also. For there was part of the plan to integrate Rust and Go together to make a faster system. So what? Let me explain a bit about the project structure so that anyone who is interested in perusing through this GitHub project can do. So in here in the GitHub, it used to have our workflows. This is now gone. Actually, all workflows are deleted because I have stopped this project. I will tell more about what happened to the project in later part of the video, so stick around and come on. So here uh, in the command directory, so our programming language actually supports wasm, so that's why we have like a separate directory just to do CLI command for wasm. You can peruse through this code yourself and do whatever you like with it. I'm not going to explain the code. Actually, I'm just going to explain what this project contains. And here we have a, a migration folder for the standard library. That was a part of the plans actually to integrate the standard library into this programming language. I mean, here is the examples. We have a bunch of examples. Actually, some of these are should not be here, like the audio player. We haven't actually implemented an audio player. Uh, there are some examples, like the command line arena is there, and then there's the Grua one. I'll tell you more a bit about the Grua example. Actually, that's also part of the language. Actually, uh, there's an HTTP example. You can actually do web related stuff with this language also. Um, we got lambda functions as an example, and we got operator overloading. Uh, and we also have relib because it's it's actually one of the libraries I intend to add to this language because I like using relib, and I intended to put relib. And actually my one of my goals was for this language is to make a video game with this language, and so adding relib support for this would be very nice actually. So here is an example code of the relib example. We can actually run this actually. So when we do this, go, yeah, I didn't install the CLI into my environment in my path actually for the Mac OS, so I'm just gonna run it via Go itself. So when we do this, we got a relib window, and here's the game. It's a simple ball catching game, and each time you catch the balls, the speed increases and whatsoever. And we can peruse through the code a bit also. So in here we have support for enums. um, Enums in this case don't behave like Rust, it behaves more like just regular enums actually. And you just declare them like this. And every by every project actually, this I will get more into that later. uh, so every project contains a main function, which is the entry point of the program. So the main function takes in no parameters, and we take the return type as int. To it's similar to C actually. We return an integer exit code like that. So in here we have the basic relib stuff, and we also have support for defer statement. uh, and in here is the how we do things with variables. So a variable in this language can either be global or local. So you can so global uh, and local are keywords in this language. So you can type global or local in here and it works. And this actually an extension that you can use to get syntax highlighting, which you see right now actually. So syntax highlighting is, I'll get more into that later. Let me just explain a bit about this code a bit. So we have every type in this language is built into the language itself. So like we have integers, strings, uh, boolean, char, so on. And so for variables are immutable by default, and we can make them mutable by adding the mutable keyword. And we also have support for Rust style declarations, which we can do with this let keyword. And it also support, we can also do let mute and also too. So like similar to Rust actually, we added this for like if you don't want to type this, uh, you can literally type this and it's type inferred by default when you use the let and let mute. And also there's a keyword called const, that's also part of the language. We'll get more into that later. So in here we have a typical while loop, and you notice we don't have the bang symbol. So we use the not is a keyword actually in this language. So you can literally do like while not and then the function. So and then it does the literal boolean operations in there. And in here, hey, you have noticed this if state equals double equals to this bracket. This is from Joy actually. I got inspiration from the Jonathan Blow for his switch statements. This is actually a switch statement, and this switch statement is exhaustive and pattern matching. So so like so we do a case here, and uh, this is how we do the how we access enums. State that, and that's how you do it. In Jai you could do like this, which is nice and clean, but we'll get more into that later. mm. So yeah, that is it. We didn't implement all really functions actually. It's only a small subset of really actually. So Yeah, this is, and that's all for this example. I will go on. Well, let's actually check out the operator overloading example. So operator overloading can be done with structs in this case. So structs are declared like this. It's In our case we call it alias functions. So why we call it an alias function is because we mm, we make basically a struct is a function that takes in arguments. That's like what's how Swift does structs. Actually, Swift literally in Swift structs are like this. Actually, you can literally declare a struct like that, and it's valid, and it looks like you're calling a function. Actually, that's the intended design goal for this, to make it look like you're calling a function. So yeah, so we have this weird syntax of making the type as struct. uh, we could there is a design goal for this, the to extend this alias functions to make it more powerful, but yeah, so let's move on. So yeah, here you can see the operators are being overloaded. So we have overloaded the plus operator and the comparison operator. So in by default, a struct type has an implicit uh, this in its data type, in the type, because if you want to access a member, you have to do like this, that the member, this is a member of a struct, and then in the you in like basic operator overloading, like you basically create a function with this operator, and then you tell what operator you want to overload, and then you give the type of operator, type of the operator you want this to overload. You can make it even do operator overload with vector too. It is possible with this. So yeah, let's move on from examples to the extensions. So I have collaborated with this Clanker to give you guys 5 extensions. So we got Emacs, we got NeoVim, we got Sublime Text, we got Vim and VS Code, because obviously I'm using VS Code. Probably these extensions are outdated because I didn't do anything. And here is the game I intended to make for you guys to showcase the features of this language, but that's dead. And in here is a lol test. So this is basically what I use to test bugs. It's literally lol. uh, so in here there's a keyword called no cache. basically uh Basically this programming language creates cache each time it executes, so so like the execution times are faster. So with this no cache keyword, we can tell the prior language don't generate cache, and just do this. And import statements are like imports. You literally do import and then the name of the module, in this case array. And you can also import other files also. This supports file, it actually supports any file. Actually, you can show here. So as you can see, the first .klang imports the app .klang, and then in our language we have namespaces. So a namespace is how we can use to access certain functions. So every function in this language is public by default. You can make a function private with the private keyword, and we can run this and it will fail because the function is not available. So it'll fail, so it failed and the function is not available because it's private. So yeah, we can move on. So in here, the lol test, we are actually doing something. So in this language, some types have properties, like they have built-in properties. So we one of the built-in properties is size of, so you can get the size of whatever data type you like. And there in here you can actually write your numbers like this, and it's looks nicer and easier to read. There's a keyword called report that reports the value of the variable in like output, and you can literally see what that value is, and it gives like debug information. And here is a basic list. And so yeah, we just it's like literally it's a literal lol test basically. And here you see this is an interesting syntax, because when we go up here we have made this thing called an alias r equal array. So notice that this array is equal to this, so that means we are referencing the namespace we call here. Otherwise you normally would have to do like array dot print or whatever this is. So you normally would do it like that, but in this case we with that special syntax, now we can simplify it by writing r and then with this colon and then the function and then whatever the function takes. And then yes, so there are many. So this is so yeah, here is one of the loops. Also we have seen the while loop before. Now we seen the for each loop. So for each loop works with iterators and list types, I believe. I cannot remember actually what's in this. So yeah, so and you can see there's an okay, that's from Rust, baby. So we go, and you notice this keyword temp. This temp keyword means you literally store the variable temporarily. You don't keep it for long. But actually there's a bug with this, so that's why it's like broken in this case. So but it still works, temp still works, but it's not in the way you expected. Temp doesn't work with const actually, so it only works with variables and like that. So oh yeah, in here's an example of a lambda function. So in lambda functions we have built-in types called function. So the function type is actually a generic type, so that it takes the it's a variadic function. It's a variadic actually, this type. So this type takes in n parameters, and this and the return value. So you can do int string, and then in here this will be inside this fun, it'll be int string, and then for that, and then you can make it return stuff. So and yeah, so this is that. And in OK there's a property called .value to expose its value, because in OK it just returns OK and value. So you can show the lol test. Yeah, there's this iterator printing. Oh yeah, this yeah, this prints. Let's disable this actually, and let's see what this is look like. Okay, let's remove the value and let's print the iterator. Print the iterator and then iterator, and then let's remove the dot value and see what it prints. So iterator, so as you can see it's OK iterator, and then the iterator thing. But if you do dot value, it gives you the value of the iterator. So it just returns the iterator, not an OK iterator. There's a reason why we added those Rust types, because there's a lot more to do with the Rust. I think why I added those Rust types is because I think it's genuinely beneficial to um, use those in actual code, actually those Rust types. So yeah, so so let's move on to how we create a project in this. So in here we need to go run dot run. Oh no, not run, sorry, it's go run dot. We get the help string. So the help string, so we have a TUI. Actually it's kind of experimental. You can literally execute whatever you like with this TUI, but we're not gonna use the TUI. We're gonna make a new project. So we literally do clang new project. So clang, oh yeah, sorry, not clang, it's if you have clang compiled and stored as a command in your system, then you can do clang like that. But I'm using go, so I'm going to do go run dot new project and see what happens. So it'll generate a template. So this is what it generates, a klang.project. This is basically the toml file of the project. Always it generates two files, the first.clang and the app.clang, and you can do two commands. You can either run the project or you can check it. And then when you check this project, let's check this out. When you check it, it will just do this like that. So it will just tell you what's in this stuff, and it type checks and see if it's working or not. So app.clang is basically what you write. It's basically the app you write, your project code. The first.clang is obviously the main program that the programming language executes, and it always takes the main function by default, because and then this is the project file. So it gives you the name of the project, gives you the entry point, gives you the language version, gives you the sources so the sources are the files that you have in this project. So yeah, and I think there is something cool I need to show you. If we go to stdlib examples array first.clang, there is something called load as script. So load as script tells the language to load the uh, program as a script and just run it as it is, because we don't always want to generate a project, and we just want to just do scripts and stuff. So that's a cool thing we can do with that. And so there's solutions. We were actually testing whether it's works with advent of code. These are from Code Wars, these two problems, and we tested it on advent of code day 1 with the input string and a solution. So we can literally run this. Oh yeah, it's loaded script, so we can do like that. Run. So it took a total of 5.2 milliseconds to run this project. It's not fast, it's very fucking slow when you think about it. Like when we tested this, it's like way slower than Python actually. Like like to print 10 million numbers from 0 to 10 million, it took like 30 seconds to do, and it's so slow actually. So here's the thing. I am not gonna show the code, you can check it out yourself. uh, so in here is the stdb lib. So how we you seen the relib example before, so we embed relib through this. So this is how we actually embed it to the Go executable. So yeah, and there's some modules that you can use. So like here's an example of struct Go module API. I doubt these are pretty useful, and also you notice there's some JSON tags. Actually, we support those in this. So like to get JSON output, I'll actually explain more on the data types after this. So here is like we got standard library, but most of the standard library doesn't work actually. It's like just prints values, it doesn't does OS level stuff. So it just prints stuff, it doesn't, you can do computations fine, but it doesn't do it. So there was plans to like make this like a pretty powerful, like see, we were even adding a HTML library also too. So yeah, that's the stdb lib, and here are the tests to just test basically what happens in here. And we were gonna make an LSP for this actually. So here is the agents.md, and here's the plans for the backends. So we were planning to make like backends for this language to improve the speed and stuff, and also memory management. Here's the code of conduct, and here is the contact is pretty useless now. Here are the data types actually in this language. So we have support for int, unsigned integer, string, float, boolean, char, map types, which takes in a generic key value and generic value, and a list, which is a variadic list of generic items, a set type, which is a generic item, option, which is also a generic item, result, which is also generic okay and generic error. We also have support for complex types. We have a SIMD type with the percentage SIMD. I don't think this is actually used. Actually, this language doesn't have good SIMD support and also complex support. We have support for functions. This is used for lambda functions, and we have T as in a built-in type. So T is the built-in type. So like T is the built-in type that everything respects. We have T and then region, generic region type, and then We have box type, we have ref type, we have ref mute, ref cell, heap allocator, heap. Yeah, there were plans to add allocators in this. So these are actually from Rust. Um, these are plans to add in actual allocators to the language that you can use, and there was an I think one of them uses an allocator. I'm not sure. We have the table data type, which is from Lua. These are concurrency types, awaitable, uh, and coroutine. We got iterator, and we got a thread type. We got args. This is the built-in array that reads command line arguments from the computer program, and this take the any type. And then we have atom support for atomics. We have a task context type. We have a channel type. We have a sender and receiver, and we got a program. These from 37 onwards is the meta programming type. So we got program, and we got build system. There was a plan to have a very powerful build system for this language. We got workspace. This is stolen from Jai. We got enum, and we got context. We got error context. We got type. We got JSON. We got parsable. This parsable is actually used for macro system. We got file for file IO. We got OS for OS. We got atom, which is from Erlang and Lua. We got bytes. We got web body. Yeah, this is the recent types. These are for the web related stuff. We got bytes, web body. Web is the immutable type. We got web URL, web headers, web request, web response, web cookie, web router, web server config, syntax node, source span, passable report, and the list goes on. It's like a huge ass list, actually. Okay, so this is the cool one. We had plans to make this the main entry point that the Go front end go no, not the Go front end, sorry, the Go source code calls from. So like whenever you run the Go CLI, this always triggers this default program. Actually, the plan was to like I was inspired by Jai, actually by Jai. It's called Jai's default meta program. So that default meta program is what Jai uses to do everything in it. So yeah, this is also inspired by Jai. We have the run keyword, and uh, yeah, there was a huge thing going on. We have built-in assert, actually, so we can do asserts, and then I don't think this will work, this program. Yeah, it has failed. Oh, must load a script. Oh, okay. Load script. Okay. Okay, now it failed. Yep, it failed. This program is broken, basically. Yeah, but the plan was to make this like the default program that calls. So, so yeah, this was the plan to make the default program a thing, and then this is an example program for .clang. It works fine. So it just does this. Oh, so wait, what? What happened? Ah, sorry, I forgot the flag. Go run dot. Yeah. So yeah, it does this stuff. So it does some printing, and there was we added this index.html because we were making a website for that, and here we were testing the JS stuff. I think this JS stuff is now broken because we were adding JS interop and backend annotations for this. there was language feature and priorities we were doing, and then the yeah, I was doing this little by little with the Clanker support. So yeah, and here we have a spec for the language. Also here we have the license. So the license is MIT, but I'm not gonna continue developing this project actually. So you can be free to do whatever you want with it actually. So yeah, here's the logo. The logo is just AI generated, of course. I couldn't draw a logo actually. I was too lazy to do that. Oh yeah, and you notice this little robot? This guy is our CLI mascot, which is printed by this mascot.co. And we had ideas to make the meta programming better actually in this language. And then there's also another plan to integrate default program, and then there's a progress.md, there's a runtime spec, and then the Rust engine integration, and the stdlib migration, and then the speed up plans, and then the web built-in and http roadmap, and a user guide for how to peruse through the code base, and workflows to if you want to reinstate the project yourself and give the workflows. Yeah. um, and to do that, these are my ideas that I think would be nice. But yeah, so yeah, so why did I stop this project? So I stopped this project because I was genuinely demotivated from doing this, because the Clanker is just literally doing it, and it just ruins the fun out of coding the program actually. And yeah, like I literally let the Clanker do it. Why I let the Clanker did it, because I wanted to explore what it's like to do a fully vibe coded project and stuff. And yeah, and I was also demotivated to continue, and also I had my free trial over, so I don't want to like actually spend money on ChatGPT. I don't want to actually genuinely do that. I would rather 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 not spend money on ChatGPT actually. And yeah, so if you are interested in this project, or like you want to continue and develop it for yourself, go ahead. The framework is there for you. You can do whatever you like with the project. I don't mind. Feel free to do whatever you want. Make it your own language. If you like the syntax design of my language, go ahead, use it. I personally think the syntax is pretty cool actually. And yeah, if you want, and I'm handing it over to whoever is watching this. If you're interested, go ahead, clone and fork the project. It's all yours. And project is available through the GitHub link in the description down below. So you can do whatever you want with this project. The world is your oyster. So yeah, I've been ranting so long for this on this. So thank you for watching and have a nice day. Bye bye.